All right, thank you for coming to Harmonization and Schema Transformation of Existing Spatial Data. Today we've got quite a bit to show you. My name is Dean Hintz. I'm from Safe Software from Vancouver, Canada. And I have with me Soren Ducke from Contera from Germany. And Safe and Contera work together on a lot of things, and Inspire is one of them. And today we're going to show you, in terms of actually implementing Inspire, how do we go about integrating the diverse range of source data that you might have to deal with. Because the whole Inspire infrastructure is very powerful in terms of being able to share data, but in order for that infrastructure to work, you have to load it first, and that's really the big challenge. So I'm going to talk first a bit about FME tools for supporting Inspire, some of the basic harmonization principles, what are the key challenges that we have to overcome, and some examples of FME tools that help you overcome those challenges. And then Soren's going to go through the Inspire Solution Pack for FME, and it's an extension to FME that Contera has developed that makes that effort a lot easier, because they've done the heavy lifting when it comes to both architecting the FME models and also interpreting the Inspire specifications. And then I'll wrap up with a few words about reading and consuming Inspire, because once we go to all this work of creating and populating the Inspire infrastructure, well, what use is it if we can't actually consume it? So we'll talk a bit about that. So just a few words about FME and Inspire, and then I'll also give you a brief overview of FME. Maybe before I get into that, a show of hands for those of you who know what FME is or have used FME. Okay, so about half of you. And I'm not so much here just to promote FME, but to talk about ETL. So, for example, Safe Software does the ETL or the data interoperability extension for ArcGIS, and so that, in the context of ArcGIS, that's called an ETL tool. And there are other software tools out there that do ETL. ETL stands for extract, transform, and load. So some of these concepts could also apply to those other tools. In the context of FME and Inspire, our goal is to provide you with all the tools you need to do the data harmonization and load the Inspire infrastructure. And then we have a number of partners that have applied FME technology to develop solutions either for their specific countries or more general solutions like Contera's, which can be applied in any context. And Soren will get into the detail of that later. So just a few words about Safe Software. We're from Vancouver, as I said, from Canada, close to 100 employees, and we have many certified professionals around the world, many partners, 50 plus partners and system integrators in 35 countries. And people are probably more than 120 countries now, people are using FME. So it's certainly a globally used product. So just a few intro slides about FME for those of you who maybe are not as familiar with it. There's three main concepts, and this does relate, I'll relate this directly to Inspire in a couple minutes, and you'll see some common threads. FME is centralized, semantic, and transformational. What does that mean? Well, there are many ways that you could do data harmonization. Let's say the simple CAD to GIS problem. You could write a translator for every CAD format to every GIS format. So you could have DWG to shape and MicroStation to map info tab, et cetera, et cetera. And then you have a whole library of transformation routines. And those you could call those bilateral. FME has a different philosophy. It's centralized, so all you have to do is define the transformation from any given data model or format to FME, and then from FME to any destination. And then you can do the data modeling independent of format internally within FME. So that's what we mean by centralized. Semantic, that means that we preserve the meaning. There's a lot of tools out there. Let's say you want to publish something to KML. A lot of tools will just take whatever data you have, let's say a shapefile, publish it to KML, and you just get this kind of white blob of data sitting on the Earth's surface, but there's no styling, there's no information or attribution. That's of limited use, especially when we talk about Inspire. We really need all the richness of any source data model that you have, because you need to be able to map that to the Inspire schema. So it's very critical that the tool that you have to do the data integration supports as much of the source data model as possible. I know in the abstract we mentioned a little bit about CAD, so I want to make sure I use some CAD examples. I know a lot of people, those of us who work in GIS, sometimes think everybody uses GIS, but a lot of times the source data might be a non-spatial table, might be an Excel spreadsheet, the source data might be AutoCAD or MicroStation. And in the case of CAD data, a lot of the semantic information is contained in the styling of how that data looks, the color or the line pattern. And that ultimately needs to be extracted and somehow mapped to the Inspire schema. When we talk about transformational, in a minute I'll show a few examples of that. Transformational talks about transforming both the geometry and the attributes. So whatever, in most cases, the output we want does not have the same data model as the input. And, well, why are we getting into transformation? A lot of people know about FME in terms of format translation, but what we found when we go from one format to another, underneath the reading and writing of data, there's also a data model change. So the CAD world sees the world as drawings with dimensions and line patterns. The GIS world is very much relational or record-oriented features with geometry and attributes. So it's a very different fundamental data structure. Just like when we go from CAD or GIS data to Inspire, it's a very different schema. And so that kind of transformation is fundamental. So in terms of the type of data formats that you can transform with FME, CAD, GIS I mentioned. There's also, we can consume web formats, and later on we'll talk about how can you layer Inspire services. So you might want to take a number of Inspire services and combine them to make a new service. So with FME you can read and publish web formats as well. And we support things like LiDAR, 3D, raster, etc. So these are all the different families of formats, spatial databases, XML, of course. And I'll have a few more slides later on about XML when we talk about consuming Inspire. So we support about 300 odd formats, and really any kind of spatial data out there. If there's something that we can't consume and you need it for your Inspire project, come let us know, and we can put it in our to-do list. So we read pretty much all spatial data out there, except there's maybe some internal formats that are only used inside one application. It may or may not support that. And then we support a lot of non-spatial formats. So ODBC, Oracle, SQL Server, non-spatial, you can consume that data as well. And that's also part of the transformation process. In many cases, you have to read non-spatial data and then georeference it. So geocode it, create points, and load a database. So this is just what does the transformation desktop look like. Our key interface is what we call Workbench. And on the left side here, we have our data sources. And then in the middle, we have what we call transformers, which do the transformation of the data. And on the right, we have the destination. And So in this case, I'm reading a CSV file. I'm taking XY coordinates, generating point locations, and then based on the value of one of the fields, I'm filtering the data and loading the destination database. We'll get back to this in a minute. So these workspaces can be as simple or as complex as you need to make them. It might be as simple as having a source format and a destination format, or there may be quite a few transformation steps. And as you'll see with some of Soren's examples, that can get fairly complex if the data model and the transformation is a complex one, as it is in Inspire. And that's why having the Inspire Solution Pack is very powerful, because they've done a lot of that work for you. So specifically focusing now on Inspire, how do we apply an ETL tool like FME to Inspire? As I said, we have format translation, schema mapping. There's also things like data validation. So if we're going to go to all this work of populating Inspire data sets, why not validate the data along the way? What's the point of loading erroneous or bad data? So even though you may be working on an Inspire project, you can get a lot of value out of that project if you do work that you have to do anyway. And so if you can do validation, maybe you're submitting an Inspire data set to Brussels, but you can generate a validation report saying which records need to be updated locally. And as I mentioned, integration with other web services. I don't know if we'll have time to get into it, but we can also provide metadata support. And specifically related to Inspire, I could do a whole other session just on XML, because it's a fairly in-depth topic. So FME gives you, really it gives you the ability to publish to GML and XML and consume XML without having to be an XML programmer. So with writing GML, we have a tool called Templater, which you have a template of the XML record structure, and then you can feed in FME records into that, and then consuming, we can read virtually any XML or GML that's out there, whether it's a file-based source or it's on the web. And I have some examples of that in a minute. Now back to Inspire. Again, you can see the common thread here. What are one of the driving themes for Inspire? The whole point of it is to have a common data model to promote data harmonization. And that, you can see how that parallels how FME set up. We set everything up to be centralized semantic transformation. So FME is an ideal fit for supporting Inspire. Also, open standards are critical. And with FME, we make supporting open standards one of our top priorities. And so when an open standard comes out, that's you know, an ISO standard or OGC standard, we make a lot of effort to make sure that our tools support that. So this is the whole challenge. How do you go from what you have to what you want? And I'm not saying your data necessarily looks like the picture on the left. That looks more like my office maybe. But how do we take all of our source data and then organize it in the Inspire structure? So I think I've covered that already. So I mentioned a bit, we've already talked about translation. A few more words about transformation. As I said, we can go from non-spatial to spatial. We can do geometry extraction. So take spatial data and then extract it as GML, for example. We can transform the different representations, so CAD to GIS. We can do spatial reference transformation, so between coordinate systems. and also building complex geometry. So Inspire, in some cases, you need to have, for a road, you might need an area representation and a centerline representation. So in GML, you can store multiple geometries per object. Most GIS or CAD only have one geometry per feature. So with FME, you can build that. And in many cases, you need to do interpolation or generalization. So if you have regional data sets and you need to aggregate them to a national level and then submit that, you may have very high precision, which makes the data sets very large, and you could generalize and reduce the volume of the data. This also becomes very important when you generate things like web services. And WFS is not really known to be a high performance data distribution standard. So you might need to generalize your data to reduce the volume of vertices before you publish it as a web service. Well, this is just an example of geometric transformation, something like intersection. And then I'll focus now mostly on schema transformation before I hand it over to Soren. So for schema transformation, this is really one of the key concepts I'll probably talk about in depth. Later on, I'll talk about XML. Right now, I'll focus on schema transformation. What do we mean by that? What is schema to begin with? Well, schema is just another a fancy word for data structure. And you might have a very simple source data structure, and I'll show you a good example of this in a minute. And it may simply be XY location and a place name. The destination in the case of Inspire is actually quite complex because Inspire wants to have a very rich data model that'll allow for exchange of data throughout Europe. And so it was designed to kind of capture every situation. For example, a place name, it doesn't just have a name. It has a spelling, and the spelling can be in multiple languages. So now we have a list of names for that location. And then we have to identify which character set is used, etc. So the destination, there's obviously some schema transformation that needs to happen. Now when we do schema mapping, what we're talking about, first of all, we can map the feature type name. Now what do I mean by feature type? You could also call that the layer name or the feature class. So the layer name might change. The source might be roads, the destination might be street. Then the attribute names might change. So instead of street name, you have route name or something like that. So the names can change. And then there's code lists. So you might have highway, boulevard, road, and then in the destination might be a code list. So you have 101, 102, 103, or the reverse. And then you get into conditional value mapping, and I'll show, that's easier to show by example. So in terms of what this looks like in Workbench, again, you can think of Workbench a little bit like a data flow diagram. So it shows what's the data that you start with, what are the transformation steps, and then what is the data that you want at the end. And this is the same example here, just reading a CSV file and splitting up by road type to the destination. So that's a type of feature type mapping. And here is just doing the attribute mapping so that primary direction just becomes direction, road category becomes category. So that's as simple as it can get. Or you can use a transformer here and actually do the mapping in a drop list so that if you have hundreds of names, it might be easier to use this interface. There's also an import option at the bottom where you can import that, let's say, from a spreadsheet. Now, Soren will show you some examples later on of some transformers that they have developed that customize this type of feature type mapping and attribute mapping are customized specifically for Inspire. And then you get context-sensitive help. But these are the building blocks that you get when you get FME. Now this is value mapping. So here you can see we're mapping the code from a code list number 1 means paved, code list 2 gravel. And you might say, oh, well, this looks like a lot of work to set up. And that's true. This is the whole point of this process, is that you go to the work of modeling the data flow, but then once you've modeled it once, it's fully automatable. You can call it from a command line, or you can set it up as a server process, and then, or there's just a data update. You can just run it from the desktop, but you just hit one button, and it does all of these processes. So it's a different approach to manipulating spatial data, as opposed to, let's say, a typical GIS environment where you have a menu and you interact with the data, and it's a nice interface, but it's all manual. This is all, the whole focus of this is to automate. Now I'll spend a little bit more time on this, and then I'll run the demo which shows how it works. This is an Inspire Geographic Names demo. And what we have is a spreadsheet which defines all the relationships. And is this on? Okay. With FME, there's always more than one way to do things. Sometimes people say, oh, why did you show it this way? And then somebody else showed me how to do something a different way. Well, with FME, it's almost like a Lego tool set where you can piece it together how you want, and so depending on the customer requirement, you may end up implementing it differently. Now, if you have a very simple schema mapping problem, maybe you use those individual transformers, or you want to have different the problem spread across different parts of a workspace. But another approach is you can have a schema mapping table where you define all of the mapping relationships in a spreadsheet, and then one transformer, see the schema mapper up the top, invokes all these transformations at once. So in this spreadsheet tab, where it says schema.fieldnames, we're mapping geographic names. So there's a source shape file with text, type, and type location. And we map text to name, geographic name, native value. And we map type to lowercase type and type loc to type local. And the nice thing about this approach is that you can actually give the spreadsheet to the domain experts. They can fill in the schema mapping, and they don't have to learn a new tool. They just enter the values, and the software figures it out. And this is what I mentioned earlier is the conditional mapping. So you can get a little more sophisticated. You can say, if the country name is Italy, create a field called name geographic name and set it to Italian. And if the country name is Austrian, create a field called a geographic name language and set it to German. So you can't just add N on the end. It would work, okay, Italian, it's Italy, they speak Italian, and Croatia, they speak Croatian, but in Austria, they don't speak Austrian. Well, maybe some other people might consider Austrian the language instead of German, but. So that's one example. And I'll just mention that in the attribute mapping, you could also do feature type mapping. So you could have one column where the source column is the source table name, and the destination side is the destination table name. So just different ways of doing schema mapping. So this is what the workspace looks like. And it's probably better if I just run it live. So let me just run this live. Now this might look a little bit complicated for those of you new to FME, so I'll kind of step through it slowly. So we have these at the I'm running FME 2013, which is probably not a good idea when you're doing demos. So I'll stick with 2012. Okay, because my bookmarks weren't showing up. So one way we organize workspaces is we can create these, it's just a grouping of transformers, and it's a nice way to organize things at a high level. And so you can see here, I've numbered everything. So those of you who are FME users, that's a nice way to set up your bookmarks, is if you prefix them with a number, then it orders the operation. So really what this whole workspace is a good example of is the whole ETL process. The first step in terms of data assembly, so under 1, reading the source data, selecting the areas of interest, that's all part of the E part of the ETL, the data extraction. And then under 2, we have the transformation steps. So the schema mapping, basic schema transformation and schema mapping with the spreadsheets, that's under 2. And then under 3, we have the GML generation. So you could say that's the publishing or the loading side of the whole harmonization process. So generating the required Inspire fields and then building the XML. And Soren will also show you some good examples of that in a minute using the Inspire Solution Pack. So let's just zoom into each of these tabs individually. So in terms of assembling the source data, we start off with a couple of shapefiles, and as I said, often the source data structures are a bit simpler than what we need for the destination Inspire. And really here we're just interested in, this is the country, so we just need the country name. This is a UN gazetteer data set, which is freely available for the whole globe, and so I just chose that as a good source. And you can see it's just text is the place name. So really it's just an XY location, text, and a type. And then we get some additional fields from the administrative areas. So there's a bunch of additional information there about the administrative region, country name, etc. Now what do we do with this? First of all, we don't need the whole world, so we just choose the countries that we're interested in. In this case, this demo, I'm using data for Italy, Austria, and Croatia. Now, this tester transformer can also be used for things like validation. So I could be checking not just filtering on the value of a name, but I could be checking value ranges of an integer floating point value. Then we do a spatial clip. So we clip out just the areas so we're actually using the geometry of those countries to clip the global gazetteer data set just for the points that fall within those boundaries. And then this is a key tool. Often, let's say for example, the source for your geometry data may not have all the attribute data that you need. So in FME we provide many ways of doing joins to take an ID or an XY location and grab all of the attributes maybe from a non-spatial data source that relate to it. In this case, the point on area overlay, what it does is we have a bunch of information on the points. Actually, it's the reverse. In this case, we have administrative areas, and there's a lot of information there we want to transfer to the point. And we can do that either way. And then we also have transformer, for example, a joiner, which lets you use an ID and get attributes from an associated database. Then here's the attribute copier you saw earlier in the slide. And there's the import function. So if you have a list of 50 different attributes, you can just import them. You don't have to type it. And here's the value mapper. So that's one approach. The other approach is the schema mapper approach, and that is essentially a wizard that lets you define, here are several different types of mappings at once. So mapping attributes, mapping, that conditional value mapping or mapping feature type names. And before I run it, I'll just show you what the spreadsheet looks like. So here, all in one spreadsheet, I've defined the mappings of the source field name to the destination. And here is the conditional mapping. So if country name is Austria, create a field called geographic name language and set the value to be German. So I know it's a little bit technical, but just showing you so that you've kind of seen an example of how that works. And I won't spend too much time on the GML generation because Soren will show you a solution that does all of that in the context of ArcGIS for Inspire. This is just to show you that FME can generate GML, but if you would have to basically be an Inspire expert to design all the GML output, and using the Inspire solution pack, they've done all that work ahead of time. So this is just showing only one feature type. This is not a complete solution. It's just a single feature type output. So we do some ID generation here and coordinate extraction because we need the coordinate system. And then ultimately what we have to do here is we have a template for the XML document, the header and the footer of the XML document, and then we have to insert the XML features in the middle. And then this is essentially modeling the named place record. And if this looks a bit technical, you could also think, well, if you're using the Inspire Solution Pack to generate the GML and you don't have to worry about this, this could also be useful if you need to generate a metadata record, which is in XML. So you can put the ISO 19115 schema in here, a sample record, and then the key thing is the FME fields. If I want to put in geographic name language in here, all I have to do is double click on go to the location where the language tag is, you can see on the screen there in the middle, and I double click on geographic name language, and it inserts this function call which inserts the value of the FME field at that point in the XML structure. So while this might look complicated, all you really need to do is paste in a sample XML record and then insert the field names from FME where you want to merge the feature type attributes in. So let me go ahead and run this. Well, our last step is validation. So this validates against the Inspire geographic name schema from the JRC. So I'll go ahead and run it. So you can see the various source countries here, Italy and Austria, etc. This is the source data, the gazetteer data, so it's a very simple shapefile where you can see those text type field names, XY. And here is the destination schema, essentially the Inspire schema. So name, geographic name, language, Italian, named place, there's a code for the namespace which is required to comply with the schema, and then the actual place name is Perugia. Or if we go over to Austria, we can pick a place there. I don't know if I can pronounce it, Murzischlag, and yeah, German. So that's basically a very simple example that demonstrates the concept of ETL applied to an Inspire use case. So we did the extraction, which was essentially reading the source formats here, in this case shapefile, the transformation, which was predominantly a schema transformation. We could have also done reprojection, let's say from an ED50 to ETRF89, and then finally the loading, which is, in this case, is GML generation. In the case of the Inspire solution pack, the loading process would be loading the ArcGIS for Inspire geodatabase. So just a couple of wrap-up slides before I hand it over. So as I mentioned, you could do a lot of validation along the way. You could make sure that IDs are unique. What would happen is if you don't make unique IDs and you try to generate GML, then it will fail on the schema validation. But what's the point of generating trying to generate bad GML if you can detect that problem up front? We can also do things like evaluate topology or geometric integrity. So is it really a polygon? If it doesn't close, it won't be a polygon. So again, if you try to load that into a geodatabase, you're going to get an error. But with FME, you can pre-filter it and maybe create a list, a report, maybe even a CSV file, listing the IDs and the problem from a bad record. Data gaps, bounds, you might have out of bounds data or data that wasn't transformed correctly. And in terms of publication, really that's when we talk about publishing Inspire services. And after Soren talks, I'll show you one or two quick examples of how do we consume multiple Inspire services and generate a new customized service associated with maybe a client that doesn't understand OGC standards. I think I'll probably leave it there and